Imagine leaving Earth tonight, not to orbit the Moon, not to reach Mars, but to cross the distance to another star, a planet called Proxima B. With today's technology, this journey would take more than 400 years. Generations would be born, live and die inside a spacecraft before arrival. But some scientists believe another possibility exists, a future where the same journey could take not centuries, but days. Before we continue, subscribe to Theories Before Sleep, where calm science and distant worlds carry your mind beyond Earth. Because this story is not just about speed, it is about the limits of physics, the boundaries of human engineering, and the strange ideas that may one day rewrite how we travel through space. Tonight, we will explore what Proxima B really is, why it became humanity's closest potentially habitable target, how long it would take to reach it using current spacecraft, what technologies could reduce the journey from centuries to weeks, and whether faster-than-light shortcuts exist or remain impossible. A nearby star, a distant world, and two very different futures of interstellar travel. Let's begin. Proxima B was not discovered by looking directly at its surface. It was discovered through movement, through subtle shifts in starlight that revealed the presence of something invisible. At the center of this story is Proxima Centauri, the closest star to our Sun, only 4.24 light-years away. In cosmic terms, this distance is extremely small, but in human terms, it is unimaginably vast. Proxima Centauri is a red dwarf star, small, cooler than the Sun, dimmer in visible light. Yet it is also highly active. It releases powerful stellar flares, bursts of radiation, streams of charged particles, and around this volatile star orbits Proxima B, a planet roughly the size of Earth, located in what scientists call the habitable zone, the region where temperatures could allow liquid water to exist. This combination immediately attracted attention. A nearby Earth-sized planet, orbiting the closest star to our solar system, potentially capable of supporting liquid water. No other known exoplanet checks these boxes so clearly. Now consider how Proxima B was detected. Scientists used the radial velocity method. Instead of watching the planet cross the star, they measured tiny wobbles in the star's motion. As a planet orbits a star, gravity causes both bodies to move around a shared center of mass. This movement shifts the star's light slightly toward red or blue wavelengths. By measuring these shifts, scientists can calculate the presence of orbiting planets. In 2016, this technique revealed a repeating signal, a small, steady tug. Proxima B was there, orbiting its star every 11.2 days. This short orbital period tells us something important. Proxima B is extremely close to its star, much closer than Earth is to the Sun. But because Proxima Centauri is much dimmer, this close orbit still places Proxima B within the habitable zone. Now consider what habitable zone actually means. It does not guarantee life. It does not guarantee oceans. It only means surface temperatures could allow liquid water under the right conditions. Many factors still determine whether water actually exists. Atmosphere thickness, cloud coverage, greenhouse effects, planetary rotation, magnetic protection. Proxima B's environment remains uncertain. But proximity makes it special because distance changes everything. Kepler 452b was more than 1,000 light-years away. Proxima B is just over 4. This makes Proxima B the closest potentially habitable exoplanet ever discovered. Now consider what 4 light-years really means. Light travels at nearly 300,000 kilometers per second. Even at this incredible speed, it takes more than 4 years for light to travel from Proxima Centauri to Earth. No human-made object comes close to this speed. The fastest spacecraft ever launched, Voyager 1, travels at about 17 kilometers per second. At that speed, reaching Proxima Centauri would take over 70,000 years. Even faster probes like Parker Solar Probe, which reaches around 190 kilometers per second near the Sun, would still require thousands of years. This is the first harsh reality. Proxima B may be close in cosmic terms, but it is still far beyond reach using current propulsion. Now consider the concept of a 400-year journey. This number often appears in discussions of interstellar travel. It represents optimistic near-future technology, faster than current spacecraft, but still within conventional physics, ion drives, nuclear propulsion, fusion concepts. Even with these advanced systems, reaching a significant fraction of light speed remains extremely difficult. At best, humanity might reach around 1% of light speed with extreme engineering. At 1% of light speed, the journey to Proxima B would take about 424 years, which means no single human crew would survive the full trip. It would require generation ships, multi-century missions, self-sustaining spacecraft where multiple generations are born, live, and die before arrival. This introduces enormous challenges: psychological stability, genetic diversity, resource recycling, social structure, technical maintenance over centuries. A spacecraft is not just a vehicle. It becomes a small artificial civilization, and maintaining civilization inside a metal shell for hundreds of years is unprecedented. Now consider communication. During a 400-year journey, communication delays would increase. Messages sent back to Earth would take years to arrive. Instructions would be outdated. Help would be impossible. The crew would be completely isolated. They would become a separate branch of humanity. Now consider motivation. Why would people agree to board a ship knowing they will never see Earth again? Knowing their children will never see Earth? Knowing arrival is not guaranteed. This raises ethical questions. Who chooses to go? Who decides the mission? Who controls reproduction and resources? Generation ships are not just engineering challenges. They are social experiments. Now consider Proxima B's environment again. The star is highly active. Red dwarfs emit powerful flares. Proxima Centauri produces radiation bursts that could strip planetary atmospheres. If Proxima B lacks strong magnetic protection, its surface may be exposed to harmful radiation. Even if liquid water exists, life may struggle under constant stellar bombardment, which means humanity could spend centuries traveling to a world that is ultimately hostile. Now consider uncertainty. We do not know Proxima B's atmosphere. We do not know its surface conditions. We do not know if it has oceans. We do not know if it has magnetic protection. We do not know if it has thick clouds that block radiation. Traveling for centuries without knowing the destination's true environment is a massive risk. Now consider the alternative scenario. What if technology changes everything? What if future propulsion methods allow speeds far beyond chemical rockets? What if the journey could be reduced from centuries to years, or months, or days? This is where the second part of the story begins. But before we reach that future, we must understand the limits, because every dream of faster travel must face the reality of physics, energy requirements, relativity, mass constraints, acceleration limits. Now consider energy. To accelerate even a small spacecraft to a significant fraction of light speed requires enormous energy, more energy than many countries produce in years. This is not a small technical problem. It is a civilization-scale challenge. Now consider heat. High-speed travel through interstellar space creates particle impacts. Dust grains become high-energy projectiles. At near light speeds, even tiny particles can damage spacecraft. Protecting against this requires advanced shielding, which adds mass, which increases energy requirements. Now consider deceleration. Reaching Proxima B is only half the problem. Slowing down to enter orbit requires the same amount of energy as acceleration. Without efficient braking methods, spacecraft would simply pass by the planet at extreme speed. Now consider the psychological contrast. 400 years feels impossible to humans. It exceeds lifetimes. It exceeds political stability. It exceeds cultural continuity. This time, scale makes interstellar travel feel unrealistic. Yet in cosmic terms, 400 years is nothing. Stars exist for billions of years, galaxies for trillions. The universe does not care about human impatience, but humans do. Which brings us to the central contrast of this topic. 400 years versus 15 days. One represents the slow, realistic future under known physics. The other represents speculative ideas that challenge the limits of reality itself. And to understand how such a dramatic reduction could even be imagined, we must explore the strange concepts scientists and theorists have proposed. Concepts that bend space, manipulate energy, and test the boundaries of what is physically possible. That is where this journey continues next. To understand how a journey of 400 years could ever be reduced to days, we must first confront the true barrier of interstellar travel. Not distance, but energy. Every object with mass resists acceleration. The heavier it is, the more energy is required to move it faster. And when approaching relativistic speeds, near the speed of light, this resistance becomes extreme. According to Einstein's theory of relativity, as an object accelerates closer to the speed of light, its effective mass increases. Not in a physical sense, but in how much energy is required to keep accelerating it. This means there is no simple way to just go faster. The closer you get to light speed, the more energy is required for smaller gains in speed. This is why 1% of light speed is already incredibly difficult, and why 10% becomes almost unimaginable. Now consider what it would take to reach Proxima B in 400 years. This requires reaching speeds around 0.01 times the speed of light, that is roughly 3,000 kilometers per second. For comparison, chemical rockets operate at exhaust speeds of only a few kilometers per second. Even nuclear thermal rockets reach tens of kilometers per second. Ion drives can reach higher exhaust velocities, but produce very low thrust. They take years to accelerate spacecraft. To reach thousands of kilometers per second, entirely new propulsion systems are required. Now consider nuclear fusion. Fusion is the process that powers stars. By fusing light atomic nuclei together, massive amounts of energy are released. If humanity could build compact fusion engines, spacecraft could achieve much higher exhaust velocities. Fusion-powered rockets could theoretically reach a few percent of light speed. This would reduce travel time to Proxima B from tens of thousands of years to a few hundred, which brings us back to the 400-year estimate. Fusion propulsion is not science fiction. It is physically possible, but it is technologically extreme. Controlled fusion remains one of humanity's greatest engineering challenges. We can produce fusion reactions in laboratories, but sustaining them efficiently and safely in a spacecraft environment remains unsolved. Now consider antimatter. Antimatter is the most energy-dense fuel known. When matter and antimatter collide, they convert nearly all their mass into energy. According to Einstein's equation, E equals mc squared. This produces enormous energy from small amounts of mass. In theory, antimatter propulsion could reach much higher speeds than fusion, possibly several percent of light speed. But antimatter has its own problems. It is extremely difficult to produce, extremely difficult to store, extremely dangerous. Even micrograms of antimatter release enormous energy. Scaling this to spacecraft propulsion would require unprecedented containment technology. Now, consider light sails. Instead of carrying fuel, spacecraft could use large reflective sails pushed by powerful lasers. Light carries momentum. When photons hit a surface, they transfer a small push. With extremely powerful lasers, this push can accelerate lightweight spacecraft to high speeds. Projects like Breakthrough Starshot propose sending tiny probes to Proxima Centauri using this method. These probes could potentially reach 20% of light speed. At that speed, the journey would take around 20 years, not days, but far shorter than centuries. However, this method works best for extremely small probes, not human spacecraft. Scaling light sails for crewed missions introduces massive engineering challenges. Sails would need to be enormous. Laser systems would need to be planetary scale. Deceleration at the destination remains a major problem. Now consider time dilation. At high speeds, time itself behaves differently. According to relativity, time slows down for objects moving close to the speed of light. This means astronauts traveling at relativistic speeds would experience less time than observers on Earth. If a spacecraft traveled at 90% of light speed, the crew might experience only a few years of travel while decades pass on Earth. This sounds promising, but reaching such speeds requires energy levels far beyond current capabilities. And even at 90% of light speed, the journey to Proxima B would still take years from the traveler's perspective, not days. Now consider the idea of 15 days. This number does not come from conventional propulsion. It comes from theoretical concepts that attempt to bypass the speed of light limit, not by moving faster, but by changing how space itself behaves. This leads us into the realm of speculative physics. Now consider the concept of warp drive. The most famous theoretical model is the Alcubierre drive. This concept involves contracting space in front of a spacecraft and expanding space behind it. The spacecraft itself does not move faster than light. Instead, space moves. In theory, this could allow effective, faster-than-light travel without violating relativity. In such a scenario, a journey to Proxima B could take days or even hours. However, this concept comes with enormous problems. It requires exotic matter with negative energy density, something that has never been observed in usable form. It requires energy amounts comparable to entire stars. It may create intense radiation hazards. It may be unstable. At present, warp drives exist only on paper. They are mathematical solutions, not engineering designs. Now consider wormholes. Wormholes are theoretical tunnels through space-time that connect distant regions of the universe. If stable wormholes existed and could be controlled, they could allow instant travel between stars. Traveling to Proxima B would become a step through a cosmic doorway, but wormholes face similar problems. They require exotic matter to remain stable. They may collapse instantly. They may not be traversable. They may not exist at all. Again, this is theoretical physics, not practical engineering. Now consider the difference between possibility and feasibility. Physics allows certain solutions mathematically, but engineering requires materials, energy, stability, safety. Many things are possible in equations, but impossible in reality. This gap is enormous. Now consider the human tendency to imagine shortcuts. Humans want faster solutions, instant results, immediate access. But the universe does not offer shortcuts easily. It enforces limits: speed of light, energy conservation, causality. These laws are not suggestions. They are fundamental. Now consider why scientists still study these ideas. Not because they expect warp drives next year, but because exploring the boundaries of physics reveals deeper understanding. Even if warp drives never become real, studying space-time geometry improves knowledge of gravity. Even if wormholes never become usable, they reveal insights about black holes and quantum physics. Speculative research pushes theoretical boundaries. Now consider realistic future timelines. In the near future, humanity may develop faster electric propulsion, better nuclear systems, more efficient fusion reactors. These may reduce travel times modestly, from thousands of years to hundreds, from centuries to decades. But reaching 15 days remains extremely unlikely under known physics. Now consider the psychological contrast again. 400 years feels too slow. 15 days feels magical. One is grounded in physical limitation. The other exists at the edge of imagination. This contrast makes the topic powerful. It highlights the tension between dream and reality, between aspiration and constraint, between science fiction and science. Now consider the deeper question. Should humanity aim to reach Proxima B physically, or should it focus on robotic exploration and observation? Sending humans across interstellar space is extremely risky. Robotic probes can be much smaller, faster, cheaper, more practical. Light sail probes may reach Proxima Centauri within decades. They could send back images and data. This may be humanity's first true interstellar mission. Not people, but machines. Now consider what this means emotionally. Humans often want to go themselves, to step on alien soil, to experience new worlds. But interstellar space may not allow this easily. The first contact with Proxima B may come through pixels, data, signals, not footsteps. Now consider the final thought of this part. Reducing a 400-year journey to 15 days is not currently realistic. It requires physics beyond our current understanding. But exploring these ideas is not meaningless. It pushes boundaries, inspires innovation, expands imagination, and sometimes today's impossible becomes tomorrow's technology. But not always. The universe sets limits, and understanding those limits is as important as dreaming beyond them. Which leads us to the next question. If faster-than-light shortcuts remain theoretical, what is the most realistic future path for reaching Proxima B? What will humanity actually do? That is where the story continues. If warp drives and wormholes remain distant theories, then the future of reaching Proxima B becomes much quieter, less dramatic, more patient. Because the most realistic path forward does not involve bending space or breaking light speed. It involves building better machines, smaller, faster, smarter, and accepting that interstellar travel will begin without humans. Now consider the most serious proposal humanity has today. Breakthrough Starshot. This project does not aim to send people. It aims to send tiny probes, spacecraft weighing only a few grams, attached to ultra-thin light sails, powered by powerful laser arrays based on Earth. The idea is simple in concept. A ground-based laser system fires concentrated beams of light at a reflective sail. The sail is pushed forward by photon pressure. Acceleration happens extremely fast. Within minutes, the probe could reach 20% of the speed of light. At this speed, the journey to Proxima Centauri would take about 20 years, not centuries, not millennia, but decades. This is a massive improvement. Now consider what these probes could do. They would not land. They would not stop. They would pass through the Proxima Centauri system at extreme speed, taking images, measuring magnetic fields, analyzing radiation, scanning for atmospheres, collecting data during a brief flyby, then transmitting that data back to Earth. Signals would take over 4 years to arrive, meaning humanity would receive the first images of Proxima B decades after launch. This is slow by human standards, but fast by interstellar standards. Now consider the challenges. Laser systems powerful enough to accelerate these probes do not yet exist. They would require enormous energy, precise targeting, atmospheric correction, adaptive optics. Even slight misalignment could destroy the probe. Now consider the probe itself. It must survive extreme acceleration, intense radiation, interstellar dust impacts, temperature extremes, communication challenges across light years, all in a package smaller than a smartphone. This is not easy, but it is within the realm of engineering. Unlike warp drives, unlike exotic matter, unlike space-time manipulation, this makes light sail probes the most realistic interstellar technology humanity currently has. Now consider what happens after robotic flybys. If Proxima B appears promising, if images show atmosphere, clouds, possible oceans, then interest will grow, not for immediate colonization, but for deeper study. More probes, more missions, more data. Human missions would still remain far away, but knowledge would increase. Now consider another realistic approach. Nuclear propulsion. Nuclear fission engines could power spacecraft more efficiently than chemical rockets. Nuclear fusion engines, if developed, could push speeds even higher. These systems could send larger robotic probes, perhaps even crewed missions someday, but still on multi-decade or century timescales, not days. Now consider generational technology development. Space travel does not advance overnight. It evolves step by step. Chemical rockets to ion drives to nuclear systems to fusion. Each step requires decades of research, testing, failure, refinement. Proxima B will not be reached by a single breakthrough. It will be reached by accumulated progress. Now consider the idea of human travel again. Even if fusion propulsion becomes practical, human missions remain extremely difficult. Life support systems must operate for decades. Radiation shielding must protect crews from cosmic rays. Psychological challenges must be addressed. Social systems must remain stable. A spacecraft becomes a small society with laws, culture, conflict, cooperation. Sending humans across interstellar space is not just an engineering challenge. It is a sociological one. Now consider the difference between exploration and settlement. Exploration is about learning. Settlement is about staying. Reaching Proxima B does not mean humanity would live there. Proxima B's environment may be hostile. Strong stellar flares, radiation exposure, atmospheric uncertainty, surface conditions unknown. Even if liquid water exists, long-term habitability is not guaranteed. This means Proxima B may be a scientific destination, not a new home. Now consider the misconception of habitable zone. Being in the habitable zone does not guarantee Earth-like conditions. Red dwarf stars behave differently from the Sun. Their habitable zones are much closer. Planets in these zones are often tidally locked, one side permanently facing the star, one side in permanent darkness. This creates extreme temperature differences. Atmospheric circulation may redistribute heat, or it may not. We do not yet know. Proxima B may have a permanent day side and night side. This would shape climate dramatically. Now consider radiation again. Proxima Centauri is active. It produces frequent flares. These flares release high-energy radiation. If Proxima B lacks strong magnetic protection, its surface could be bombarded constantly. This could strip atmosphere, damage potential life, create harsh surface conditions. This makes Proxima B a risky destination even if reachable. Now consider why humanity still cares. Because proximity matters. Proxima B is the closest exoplanet in the habitable zone. It is the first realistic interstellar target. Not because it is perfect, but because it is nearby. It represents the doorway to interstellar exploration, not the final goal. Now consider the psychological shift this creates. For centuries, stars were unreachable, untouchable, purely visual. Now humanity is developing technology that can physically reach another star system, even with robotic probes. This is a historic transition. It marks the beginning of interstellar capability. Not travel, but reach. Now consider what this means for civilization. The first interstellar probe will become a symbol, like the first moon landing, not because of practical benefit, but because of what it represents. Humanity extending its reach beyond the solar system, crossing the boundary between local space and interstellar space. Now consider time again. A 20-year journey may not sound fast, but it fits within a human lifetime. Scientists who launch the probe may live to see the data return. This creates emotional connection, unlike 400-year missions, which disconnect generations. Now consider funding and politics. Large interstellar projects require international cooperation. They require long-term commitment, stable funding, scientific consensus, public support. This is difficult. Governments change, priorities shift, but interstellar exploration requires patience, which is rare in modern politics. Now consider the future scenario. A light sail probe launches. It accelerates. It leaves the solar system. It travels for decades. Then it enters the Proxima Centauri system. It sends back the first close-up images of another Earth-sized exoplanet. This moment would be historic, not dramatic, not explosive, but emotionally powerful. It would mark the first time humanity sees a true alien world up close, not through telescopes, but through direct measurement. Now consider the contrast with the 15-day fantasy. That version imagines instant arrival, human footsteps, immediate exploration. But reality is slower, quieter, more patient, less cinematic, but more achievable. Now consider the deeper lesson. Interstellar travel is not about speed alone. It is about sustainability, reliability, incremental progress, trust in long-term projects. Humanity does not leap across the stars. It steps slowly, one technology at a time. Now consider the closing thought of this part. The most realistic future of reaching Proxima B does not involve bending space-time. It involves building smarter probes, more efficient propulsion, better communication systems, and accepting that the first visitors will not be humans. They will be machines, carrying cameras, sensors, and humanity's curiosity. They will cross interstellar space quietly, without applause, without celebration, just motion, light, data, and time. And when their signals finally reach Earth, they will bring something more valuable than speed. They will bring knowledge, and that knowledge will shape how humanity imagines its future among the stars. Which leads us to the final question. If Proxima B is reachable only through patience and machines, what does that say about humanity's dreams of interstellar civilization? And how realistic are those dreams? That is where this journey continues next. When humanity imagines an interstellar future, the image is often dramatic. Starships crossing galaxies, civilizations spreading across stars, new worlds becoming homes. But when the reality of Proxima B is placed beside these dreams, a quieter picture emerges. One shaped by limitation, by patience, by the slow rhythm of technological progress. Because interstellar civilization is not built on speed alone, it is built on sustainability. Now consider what it truly means to become an interstellar species. It does not mean simply reaching another star. It means maintaining continuous presence beyond the solar system. It means creating systems that can survive for decades, centuries, and eventually millennia. It means building technology that does not fail when Earth is far away. This is far more difficult than launching a probe. Now consider the infrastructure required to support interstellar missions. Humanity must develop reliable long-term energy systems, closed-loop life support, radiation shielding, autonomous maintenance, artificial gravity solutions, psychological support systems. None of these are fully solved today. The International Space Station struggles with maintenance after only a few decades in orbit. Now imagine maintaining a spacecraft traveling for generations. This is not just engineering. It is biology, sociology, psychology. Now consider generational ships again. These are spacecraft designed to carry humans across interstellar distances over centuries. The original crew would never arrive. Their descendants would. This raises deep ethical questions. No one on the ship chose to be born into that mission. They inherit it. They cannot turn back. They live inside a closed artificial world. Their entire reality becomes the spacecraft. Now consider social stability. Small isolated populations face unique challenges: conflict, inequality, power dynamics, cultural stagnation, psychological stress. Maintaining harmony inside a metal habitat traveling through empty space for centuries is unprecedented. Even on Earth, isolated communities experience conflict. Now imagine isolation without escape. Now consider resource management. Generation ships must recycle everything: water, air, food, waste. Any system failure becomes catastrophic. There is no resupply, no rescue, no emergency return. The margin for error is extremely small. Now consider radiation again. Interstellar space is filled with cosmic rays, high-energy particles that damage cells and electronics. Long-term exposure increases cancer risk, damages DNA, degrades materials. Protecting humans from radiation over centuries requires heavy shielding, which increases spacecraft mass, which increases energy requirements. Now consider energy production. Solar power becomes weak, far from stars. Nuclear power becomes necessary. But nuclear systems must operate safely for centuries, without maintenance by Earth-based teams. This is an enormous challenge. Now consider the arrival problem. Even if a generation ship successfully reaches Proxima B, what awaits them? An uncertain planet, possible radiation storms, unknown atmosphere, unknown gravity, unknown surface conditions. The destination may not support human life, which means the ship itself remains the primary habitat, not the planet. Now, consider the idea of colonization. Colonization implies building permanent settlements. This requires stable environments, local resources, compatible gravity, acceptable radiation levels. Proxima B may not provide these, which means interstellar colonization may not resemble Earth expansion at all. It may be limited to artificial habitats, space stations, orbital colonies, rather than planetary surfaces. Now consider the psychological impact of this reality. Many imagine interstellar travel as freedom, adventure, new beginnings. But the reality may be confinement, living inside machines, dependent on technology, separated from natural ecosystems, separated from Earth's biosphere. This is not inherently bad, but it is different from fantasy. Now consider the contrast with robotic exploration again. Machines do not need air. They do not need food. They do not suffer isolation. They do not experience boredom or fear. They can travel for decades without complaint. This makes them ideal pioneers. Robots can explore hostile environments, transmit data, and prepare maps. Humans may follow later, or not at all. Now consider economic motivation. Interstellar travel is extremely expensive. It requires massive energy investment, infrastructure, long-term funding. What economic incentive exists? Mining, resources, colonization. At present, no known resource on Proxima B is worth the cost of interstellar transport, which means interstellar exploration is driven by curiosity, not profit. This makes it fragile, because curiosity must compete with immediate needs: healthcare, education, climate management, social stability. Funding interstellar projects requires long-term vision. Now consider political stability. Interstellar missions require decades of consistent policy, stable institutions, international cooperation. This is difficult. Governments change, priorities shift, conflicts arise. Maintaining continuity across generations is rare. Now consider humanity's track record. Large projects often face delays, budget cuts, political interference. Yet some long-term projects succeed. Space telescopes, particle accelerators, climate research networks. These show that humanity can cooperate when goals are shared. Interstellar exploration may require a similar approach. Now consider cultural evolution. If humanity becomes interstellar, culture will change. Distance will create separation. Communication delays will fragment civilization. Earth and interstellar outposts will evolve independently. Languages may diverge. Values may shift. This creates multiple versions of humanity, separated by light years. This is not science fiction. It is the natural outcome of distance. Now consider the emotional weight of separation. Families separated permanently. Friends lost to distance. Generations growing up without Earth. This is the human cost of interstellar expansion. Now consider the question again. Is interstellar civilization realistic? Not in the near future, not on a large scale, not with current technology, but limited interstellar presence may be possible. Robotic probes, small research missions, perhaps one day small human habitats, but galaxy-wide civilizations remain far beyond current capability. Now consider what Proxima B represents in this context. It is not the gateway to a vast empire. It is a test case, a nearby laboratory, a proof of concept. It allows humanity to experiment with interstellar technology on the smallest scale possible. Closest star, shortest distance, lowest energy barrier. If humanity cannot reach Proxima B effectively, it cannot reach any other star system. Now consider patience again. Interstellar civilization is not built in decades. It is built in centuries, slowly, carefully, incrementally. Each generation builds on the last. Now consider the emotional shift this requires. Modern culture values speed, instant results, rapid growth. Interstellar exploration demands the opposite. Long-term thinking, delayed gratification, projects that outlive their creators. This is a different mindset. Now consider whether humanity is capable of this shift. The answer is uncertain, but some examples exist. Cathedrals built over centuries, scientific institutions maintained over generations, long-term climate research. These show that long projects are possible. Interstellar exploration may become another such project. Now consider the closing reflection of this part. Traveling to Proxima B is not just about engines and speed. It is about civilization itself, its patience, its cooperation, its priorities, its ability to think beyond immediate reward. Whether humanity ever becomes interstellar will depend less on physics and more on culture, values, stability, and long-term vision, which leads to the final layer of this story. If humanity cannot easily become an interstellar civilization, then what is the true purpose of dreaming about Proxima B? What role does this distant planet play in shaping humanity's future? That is where the journey reaches its deepest question. When humanity dreams about Proxima B, it is not really dreaming about one planet. It is dreaming about its future, because distant worlds become symbols, not of geography, but of possibility. Proxima B represents the nearest mirror held up to human ambition, close enough to feel reachable, far enough to expose every limitation. And in that tension between desire and reality, something important is revealed. Now consider why humans are drawn to distant stars at all. It is not practical. It is not necessary for survival. It is not efficient. Yet the desire persists because exploration is woven into human identity. From crossing oceans to climbing mountains, humans have always pushed beyond familiar boundaries. Not because it was safe, but because it answered a deeper need. The need to understand, the need to expand awareness, the need to know what exists beyond the horizon. Proxima B becomes the next horizon. Not a physical one yet, but a psychological one. Now consider how this changes priorities. When humans think about interstellar travel, they begin to question their current limitations: energy production, environmental sustainability, technological efficiency, long-term planning. Suddenly, problems on Earth become part of a larger context. Climate stability is not just about weather. It is about whether humanity can manage planetary systems. Energy efficiency is not just about electricity. It is about whether civilization can produce power at scales required for space exploration. Education is not just about jobs. It is about whether future generations can continue long scientific projects. Proxima B shifts perspective. Now consider the role of inspiration. Space exploration has always inspired technological progress: satellite communication, GPS, weather monitoring, medical imaging, materials science. Many of these technologies were developed for space, but transformed life on Earth. Interstellar research may produce similar effects. Laser systems developed for light sails could revolutionize energy transmission. Advanced materials could improve infrastructure. Autonomous systems could reshape industry. Even if Proxima B is never reached by humans, the journey toward it will still change Earth. Now consider the danger of misdirected focus. There is a risk that humanity romanticizes distant worlds while neglecting immediate responsibilities. It is easier to dream about other planets than to solve problems at home. But Proxima B does not replace Earth's challenges. It highlights them. It shows how difficult it is to create stable planetary conditions, which makes protecting Earth more urgent, not less. Now consider the emotional contrast. Looking at Proxima B creates awe, distance, mystery. But looking at Earth creates familiarity, comfort, routine, and humans often undervalue what feels familiar. Proxima B reminds humanity to look at Earth with new eyes, to see it as a rare environment, a fragile system, not guaranteed. Now consider the role of storytelling. The way Proxima B is presented matters. If it is framed as an escape, it encourages irresponsibility. If it is framed as a mirror, it encourages reflection. Science increasingly frames distant planets as tools for understanding planetary systems, not replacement homes. This shift in narrative is important. Now consider long-term survival. Humanity's long-term survival depends less on reaching other stars and more on stabilizing Earth, avoiding large-scale ecological collapse, managing resources, reducing conflict, improving cooperation. Without these foundations, interstellar projects collapse. A civilization that cannot maintain stability on its own planet cannot sustain century-long space missions. Proxima B highlights this reality. Now consider the idea of technological maturity. Interstellar travel requires more than advanced engines. It requires advanced civilization behavior, global cooperation, peaceful conflict resolution, shared scientific goals, long-term funding structures, ethical frameworks. These are social technologies, not mechanical ones. Proxima B indirectly challenges humanity to develop these systems. Now consider human psychology again. Short-term thinking dominates many decisions. Immediate rewards, quick results, political cycles, economic pressure. Interstellar exploration demands the opposite mindset. Long-term thinking, delayed gratification, projects that may not benefit the people who start them. This is rare, but not impossible. Some scientific projects already operate this way. Climate monitoring networks, astronomy observatories, space telescopes. They exist across decades. Proxima B may encourage more long-term thinking. Now consider the question of meaning again. Why does humanity want to reach the stars? Not just to travel, but to understand existence, to know whether life is unique, to know whether intelligence is rare, to know whether the universe is silent or alive. Proxima B becomes part of this philosophical search. It represents the closest chance to test these ideas beyond the solar system. Now consider uncertainty. Even if humanity sends probes, even if images are returned, even if atmospheric data is analyzed, many questions will remain. Is there life? If yes, what kind? If no, why not? Each answer creates new questions. This is the nature of exploration. Proxima B is not a final destination. It is a step in an ongoing process. Now consider humility. The universe is vast. Human technology is young. Interstellar distances expose how limited current capabilities are. Proxima B reminds humanity that progress does not make us masters of the universe. It makes us students, learning slowly, experimenting carefully, accepting limits. Now consider cooperation again. Reaching Proxima B realistically requires global collaboration, shared funding, shared infrastructure, shared scientific goals. This challenges nationalism, competition, isolation. Interstellar projects naturally encourage international cooperation because no single nation can easily fund or maintain them alone. This could influence global politics, not through force, but through shared curiosity. Now consider the emotional tone of interstellar ambition. It is not aggressive, it is quiet, it is patient, it is long-term. Proxima B does not demand immediate action. It invites gradual preparation, decades of development, generations of planning. This slow rhythm contrasts with modern urgency, and it may be healthy. Now consider the paradox again. Proxima B is close enough to feel reachable, but far enough to remain out of direct reach. This creates a productive tension. It keeps humanity dreaming while forcing realism. It prevents complacency, but also prevents reckless optimism. Now consider what happens if humanity never reaches Proxima B physically. Does the dream fail? No, because the value of exploration is not measured only by arrival. It is measured by transformation, how technology improves, how perspective changes, how priorities shift. Proxima B has already changed how humanity thinks about nearby stars. It has made interstellar space feel closer, more real. As the story of Proxima B continues to unfold, one final layer becomes clear. This journey is not only about reaching another star. It is about understanding what kind of civilization humanity is becoming. Because every great technological ambition reveals character, not just capability. Proxima B acts like a mirror held up to the future, showing both potential and weakness. Now consider the question of patience. Interstellar travel is slow by nature. Even the fastest realistic methods require decades. This forces humanity to confront its relationship with time. Modern society is built on speed, instant communication, rapid delivery, short attention cycles, immediate feedback. But the universe operates on different scales. Stars evolve over billions of years. Planets form over millions. Light itself takes years to cross interstellar distances. Reaching Proxima B requires humans to adopt a cosmic sense of time, long-term thinking, projects that outlive their creators. This is a cultural shift. Now consider whether humanity is ready for this shift. Some signs are promising. Scientific institutions plan decades ahead. Space agencies design missions that take years to launch and operate. Astronomers build telescopes that will function for generations. These projects show that long-term thinking is possible, but it remains fragile. Economic pressure, political change, global conflict, all threaten continuity. Interstellar exploration requires stability, which means humanity must learn to preserve peace long enough to pursue distant goals. Now consider the idea of legacy. Why would scientists, engineers, and nations invest in projects they may never personally see completed? Because of legacy, because of contribution, because of the desire to be part of something larger than individual lifetimes. Proxima B inspires this mindset. It represents a goal beyond personal reward, a project for humanity as a whole. Now consider how this changes the meaning of success. In many fields, success is measured by speed and profit. Interstellar exploration measures success differently, by knowledge gained, by systems developed, by understanding expanded, by collaboration achieved, not by immediate return. This challenges modern economic thinking. It introduces a different value system, one based on long-term benefit. Now consider risk again. Interstellar projects carry enormous uncertainty. Technology may fail, funding may disappear, political support may collapse, probes may be lost, data may never arrive. Yet humanity continues to pursue these goals because exploration has always involved risk, from early ocean voyages to space missions. Risk is part of discovery. Proxima B represents the next scale of this pattern. Now consider what this means emotionally. Knowing that reaching Proxima B may take decades or centuries creates humility. It reminds humanity that not every dream will be realized quickly, that progress is incremental, that patience is a form of strength. This is an important lesson in a world driven by speed. Now consider the deeper philosophical question. Why does humanity want to cross interstellar space at all? Not because Earth is inadequate, not because escape is necessary, but because understanding the universe is part of understanding ourselves. Looking outward helps humanity see inward. Proxima B becomes a tool for self-reflection. Now consider how this changes education. Future students will learn not only about planets, but about interstellar engineering, energy systems, long-term project planning, sustainability, systems thinking. Interstellar ambition encourages interdisciplinary knowledge. Physics, biology, engineering, psychology, sociology, all become part of the same challenge. Now consider the possibility of cultural unity. Interstellar projects require global participation. They encourage shared goals, shared scientific standards, shared data. This creates a sense of planetary identity, not just national identity. Proxima B belongs to no country. It belongs to humanity. This shared ownership can encourage cooperation. Now consider the emotional image again. A tiny probe leaving the solar system, accelerated by light, traveling through empty space, crossing interstellar darkness, carrying humanity's curiosity. This image is powerful, not because it is dramatic, but because it represents quiet persistence. Now consider what happens when the data returns. Years later, decades later, images arrive, spectral readings, magnetic field measurements, atmospheric hints. This moment will be historic, not because humans arrived physically, but because humanity extended its senses beyond the solar system. This is a new form of presence. Remote presence, intellectual presence, scientific presence. Now consider the emotional contrast. Humans may never walk on Proxima B, but they may see it in detail, understand its climate, map its surface features, detect its atmosphere. This changes what exploration means. Exploration becomes information-driven, not movement-driven. Now consider the possibility that Proxima B is hostile. If data reveals extreme radiation, thin atmosphere, unstable climate, then Proxima B becomes a lesson, not a destination. It teaches humanity about planetary limits, about red dwarf environments, about habitability challenges. This knowledge improves future searches. Not every discovery must be hopeful to be valuable. Now consider the possibility that Proxima B is surprisingly stable. If data reveals thick atmosphere, magnetic protection, cloud systems, possible water signatures, then Proxima B becomes one of the most important discoveries in history, not because humans will go there, but because it proves that habitable environments can exist around red dwarf stars, which expands the number of potential life-hosting worlds in the galaxy dramatically. Now consider what this means emotionally. Either outcome is meaningful. Hostile environment teaches caution. Stable environment teaches possibility. Both expand understanding. Both shape future exploration. Now consider humanity's long-term trajectory. If humanity survives long enough, if it maintains stability, if it develops advanced propulsion, then one day, perhaps centuries from now, human missions may be launched, not to Proxima B specifically, but to nearby star systems, slowly, carefully, with knowledge gained from robotic pioneers. Proxima B becomes part of this roadmap, not the destination, but the first milestone. Now consider the difference between fantasy and reality. One last time. Fantasy shows starships arriving in days. Reality shows probes arriving in decades. Fantasy shows instant colonization. Reality shows slow data transmission. Fantasy is exciting. Reality is patient. But reality is the one that builds civilizations. Now consider the final emotional layer. Proxima B represents hope, not hope of escape, but hope of understanding, hope that humanity can cooperate, hope that long-term projects are possible, hope that curiosity survives political cycles, hope that knowledge continues to grow. Now consider the closing image of this part. Earth continues to orbit the Sun. Proxima Centauri continues to shine faintly in the distance. Proxima B continues its tight orbit, silent, unaware. And between these worlds, humanity continues to think, plan, build, question, dream, not rushing across the stars, but slowly extending awareness. One probe, one mission, one generation at a time. And that is how interstellar civilization truly begins. Not with speed, not with shortcuts, but with patience, with cooperation, with persistence, and with the quiet decision to keep looking outward, while learning to take better care of the world that made this journey possible. That world is Earth, and without Earth's stability, no star will ever be reached, no matter how fast the engines become. And that truth remains at the heart of humanity's journey to Proxima B, a journey not just through space, but through responsibility, through perspective, and through time. As the journey toward Proxima B stretches across imagination and science, another realization quietly emerges. Interstellar travel is not only a technological challenge, it is a test of civilization itself. Because to reach another star, humanity must first learn how to remain stable long enough to try. Now consider the fragile nature of human progress. History shows cycles, growth and collapse, innovation and conflict, expansion and contraction. Civilizations rise with great ambition, then fall under pressure. Interstellar projects require something rare in human history: continuity. Not just years, not just decades, but centuries of stable cooperation. This is difficult. Wars interrupt research, economic crises cut funding, political change reshapes priorities. Yet interstellar exploration cannot be paused and restarted easily. It demands sustained commitment, which means humanity must evolve culturally, not just technologically. Now consider the role of shared identity. When people see themselves primarily as members of nations, competition dominates. But interstellar exploration encourages a different identity: planetary identity, seeing humanity as one species on one world. Proxima B belongs to no flag, no border, no government. It is part of the universe, not a nation. To reach it, humanity must think beyond political divisions. Now consider education again. Future generations will grow up in a world where nearby exoplanets are common knowledge. They will not see Proxima B as strange. They will see it as one of many neighboring worlds. This familiarity will shape ambition. It will normalize the idea that humanity is part of a larger cosmic neighborhood. This psychological shift is important because interstellar thinking begins in classrooms, not rocket labs. Now consider the role of storytelling. Stories shape motivation. If space exploration is told as conquest, it creates aggression. If it is told as discovery, it creates curiosity. If it is told as responsibility, it creates stewardship. Proxima B can be framed in many ways: as a prize, as a challenge, or as a lesson. Science favors the last interpretation. It is not a trophy. It is a case study. Now consider the emotional difference between proximity and reachability. Proxima B is close compared to other stars, but it is still unreachable with current human travel. This teaches a valuable lesson. Not everything that appears close is accessible. Distance in space is deceptive. What looks nearby in astronomical terms remains far in practical terms. This reminds humanity to be careful with assumptions. Now consider technological optimism. There is a belief that technology will eventually solve all problems, that faster engines will appear, that energy will become unlimited, that physics will be rewritten. While innovation is powerful, it is not unlimited. Some constraints may never be removed. Speed of light, energy conservation, biological limits, These are not temporary obstacles. They are fundamental features of the universe. Proxima B forces humanity to confront this reality. Now consider adaptation. Instead of forcing the universe to change, humanity may need to adapt its expectations, accept slower travel, accept robotic exploration, accept remote presence instead of physical presence. This is not failure. It is evolution. It is learning to work within cosmic limits. Now, consider how this changes the idea of exploration itself. In the past, exploration meant movement, ships crossing oceans, astronauts walking on the moon. But future exploration may be about information, sensors instead of footsteps, data instead of territory, understanding instead of ownership. Proxima B fits into this new model. Now consider the emotional satisfaction of discovery. Seeing the first images of Proxima B, even from a fast flyby probe, would be historic. Not because humans arrived, but because humanity extended its perception beyond the solar system. This is a different kind of achievement, less physical, more intellectual, but equally meaningful. Now consider the long-term scientific value. Studying Proxima B will improve understanding of red dwarf star systems, atmospheric retention, radiation effects, planetary magnetic fields, climate stability. This knowledge applies to thousands of similar stars across the galaxy, which means Proxima B is not just one destination. It is representative of an entire class of worlds. Now consider the idea of stepping stones. Humanity rarely jumps directly to its largest goals. It moves step by step, from Earth orbit to the Moon, from the Moon to Mars, from Mars to robotic interstellar probes, from probes to more advanced missions. Proxima B is one of these stepping stones, not an endpoint. Now consider time once more. The universe is patient. Stars shine for billions of years. Galaxies evolve slowly. Human civilization is young. If humanity survives long enough, interstellar travel will feel less impossible. Not because physics changes, but because technology improves gradually. What seems impossible today may become routine centuries from now. But this requires continuity, which returns us to the central challenge: stability. Now consider the quiet responsibility that comes with this realization. If humanity wants to reach other stars, it must first protect its home, because without Earth, no interstellar future exists, no technology, no civilization, no curiosity. Proxima B indirectly reinforces this truth. It shows how fragile habitable conditions can be, how rare stable environments may be, how valuable Earth truly is. Now consider the emotional tone again. There is no urgency to rush toward Proxima B. No countdown, no deadline. The star will still be there. The planet will still orbit. What matters is whether humanity remains capable of exploration, which depends on choices made today. Now consider the role of cooperation one last time. Interstellar projects require collaboration across cultures, across ideologies, across generations. They require trust, shared goals, common understanding. Proxima B becomes a unifying target, not because everyone wants to go there, but because everyone can participate in understanding it. Now consider the image of the future, a small probe leaving Earth, accelerated by lasers, crossing interstellar darkness. Years pass, decades pass. Then data returns. Humanity gathers. Scientists analyze. The world watches. This moment will not be loud. It will not be dramatic. It will be quiet. Screens showing faint images. graphs displaying atmospheric readings, but its significance will be enormous because it will mark the first true interstellar contact, not with aliens, but with another planetary environment. Now consider what happens after that. More missions, better probes, more targets. Interstellar exploration becomes routine, not common, but established. Humanity begins mapping nearby star systems, understanding galactic neighborhoods. This is the beginning of cosmic geography. Now consider the emotional meaning of this expansion. It does not make Earth smaller. It makes Earth more meaningful. Because Earth becomes the reference point, the origin, the home. All exploration begins here. Now consider the final reflection of this part. Traveling to Proxima B is not about conquering distance. It is about learning patience, not about breaking physics, but about respecting it, not about escaping Earth, but about understanding the universe. And perhaps most importantly, it is about understanding humanity itself, its limits, its strengths, its potential, and its responsibility. Because the path to the stars does not begin with engines. It begins with values, with cooperation, with long-term thinking, with the decision to build a civilization capable of lasting long enough to explore beyond its birthplace. That decision is not made in space. It is made on Earth, every day, in classrooms, in laboratories, in policies, in choices. And whether humanity ever stands beneath the light of Proxima Centauri will depend less on speed and more on wisdom. And that quiet truth remains at the heart of this journey, not just to Proxima B, but toward the future of civilization itself. As the journey approaches its quiet horizon, Proxima B begins to feel less like a destination and more like a symbol of how far humanity has already come and how far it still has to go. Because when humans first learned that another Earth-sized planet orbited the closest star to the Sun, something shifted. The universe no longer felt unreachable, not because it became easy, but because it became personal. Proxima B is close enough to imagine, close enough to name, close enough to study in detail. And that closeness changes the relationship between humanity and the stars. Now consider what this does to imagination. For centuries, stars were distant lights, beautiful, untouchable, abstract. Now they are systems, with planets, with orbits, with environments. Proxima B transformed one small red star into a potential world, not fantasy, not myth, but data. This is a profound shift, because imagination grounded in science becomes more powerful than imagination alone. Now consider how this affects hope. Hope is often misunderstood as optimism, as believing everything will work out. But scientific hope is different. It is the belief that understanding can grow, that knowledge can expand, that limits can be approached carefully. Proxima B represents this kind of hope, not the hope of instant arrival, but the hope of gradual progress. Now consider the idea of proximity again. 4 light-years feels close on cosmic maps, but it remains far beyond everyday experience. This tension between closeness and distance mirrors many human goals. Some dreams feel near, yet require enormous effort. Proxima B teaches patience in ambition. It reminds humanity that meaningful goals are rarely quick. Now consider what happens emotionally when people realize how long interstellar travel takes. There is often disappointment, a sense of limitation, but there is also relief. because it removes unrealistic expectations. It grounds ambition in reality. It encourages long-term thinking rather than impulsive action. Now consider the relationship between science and humility. Science constantly reminds humanity that it is not central, not dominant, not special in position. Earth is not the center of the solar system. The Sun is not the center of the galaxy. The galaxy is not the center of the universe. Proxima B continues this lesson. It shows that Earth-like planets may exist elsewhere, which reduces cosmic uniqueness but increases responsibility. Because if environments are common but life is rare, then protecting life becomes more important. Now consider how this knowledge changes priorities. Interstellar dreams do not replace planetary needs. They highlight them, because no spacecraft can leave Earth without Earth's resources. No civilization can explore the stars if it collapses at home. Proxima B indirectly demands planetary stability. It ties cosmic ambition to environmental responsibility. Now consider the quiet realization. The path to the stars does not begin with rockets. It begins with sustainable energy, with stable ecosystems, with education, with social cooperation, with long-term planning. Without these foundations, even the fastest engine is useless. Now consider the emotional effect of this understanding. It creates calm, not urgency, not panic, but clarity. Clarity about what matters first: Earth, then space. Now consider the difference between exploration and escape again. Some view space as a way to escape Earth's problems, but Proxima B shows that escape is not simple. It takes centuries, enormous energy, extreme effort. It is far easier to protect Earth than to replace it. This realization shifts motivation from running away to taking responsibility. Now consider the role of curiosity once more. Curiosity drives humans to explore even when there is no immediate reward. Proxima B offers no guaranteed benefit, no confirmed resources, no certainty of habitability. Yet it attracts attention because curiosity is not based on utility alone. It is based on meaning, on the desire to know what exists beyond the familiar. Now consider the beauty of this drive. Humans look at a faint star in the southern sky, measure tiny fluctuations in light, discover a planet, and then spend years imagining how to reach it. This process is quiet, intellectual, patient. It does not involve spectacle, but it changes perspective. Now consider the future of interstellar thinking. As more nearby planets are discovered, humanity will build a mental map of its stellar neighborhood, not for travel, but for understanding. Which stars host planets? Which planets may have atmospheres? Which systems are stable? This creates a new layer of geography, not Earth geography, but cosmic geography. Proxima B becomes one of the first landmarks on this map. Now consider what this does to human identity. Humans will no longer think only as inhabitants of Earth. They will think as members of a star system, a local cluster of stars, a galaxy. This expanded identity does not erase national identity, but it adds another layer, a cosmic layer. Now consider how this may influence conflict. Seeing Earth as one planet among many can reduce the sense of absolute ownership. Borders become less significant. Resources become more shared. Perspective widens. This does not guarantee peace, but it encourages it. Now consider the emotional tone of this realization. There is something calming about knowing humanity is part of something larger, not isolated, not alone in structure. Even if life elsewhere is unconfirmed, the universe becomes a place of connection, not emptiness. Now consider the final role of Proxima B in this story. It is not the end of exploration. It is the beginning of interstellar awareness, the moment humanity realized that nearby stars are not just lights, but neighbors with worlds. This realization will not fade. It will grow stronger with each new discovery. Now imagine the far future, centuries from now. Humanity may look back at the early 21st century as the era when interstellar thinking truly began, when the first nearby Earth-sized planets were identified, when the first serious plans for interstellar probes were developed, when Proxima B became part of public awareness. It will be remembered not for arrival, but for awakening. Now consider the final calm image. Earth continues to orbit the Sun. Proxima Centauri continues to glow faintly. Proxima B continues its tight orbit, 3 bodies connected by gravity and distance, and between them, humanity's thoughts travel, ideas, plans, dreams, questions, not at the speed of light, but at the speed of curiosity. Now, consider the closing truth. Traveling to Proxima B is not primarily about reaching another world. It is about learning to see this one differently, about understanding limits, about respecting time, about valuing stability, about recognizing responsibility. And in that sense, the journey has already begun, not with engines, not with spacecraft, but with awareness. Awareness that the universe is vast, that Earth is fragile, that humanity is young, and that the path to the stars will be shaped not by speed, but by wisdom. And with that understanding, the story of Proxima B does not end. It rests quietly, waiting, like the star itself, patient, distant, unmoving, while humanity decides what kind of civilization it wants to become. Not tomorrow, not next year, but over generations, under this sky, on this planet, in this moment. And that choice is already in motion. As the final layer of this journey settles into silence, Proxima B no longer feels like a faraway object in space. It feels like a question about where humanity is going, and more importantly, how it will get there. Because when all the numbers fade, when the engines are imagined and the timelines are calculated, what remains is not speed, it is intention. Now consider the simple truth. Humanity does not yet have the technology to reach Proxima B quickly. It does not yet have the stability to maintain century-long missions easily. It does not yet have the global cooperation required for true interstellar projects. And yet, humanity continues to plan, to design, to imagine. This reveals something essential. Progress is not driven only by ability. It is driven by direction. Now consider the difference between movement and growth. Movement is physical. Rockets leaving Earth, probes crossing space, signals traveling through the void. Growth is internal. Knowledge expanding, perspective changing, values evolving. Proxima B contributes more to growth than movement. It changes how humanity thinks about space, not as empty darkness, but as a neighborhood of potential worlds. Now consider the emotional shift this creates. The stars become closer psychologically, not physically, but mentally. People begin to imagine nearby star systems as places with planets, with environments, with potential. This makes the universe feel alive, not empty. Now consider how this affects scientific curiosity. When something feels reachable, even if distant, curiosity intensifies. Proxima B is not one of thousands of anonymous stars. It has a name, an orbit, a story. This personalizes exploration. It gives humanity a focal point. Now consider the danger of impatience. Modern culture values speed, faster internet, faster transport, faster results. But the universe does not respond to impatience. Proxima B reminds humanity that some goals require waiting, decades, generations, long arcs of development. This teaches discipline, not the discipline of force, but the discipline of patience. Now consider the role of responsibility again. If humanity wants to reach other stars, it must first preserve the only platform capable of launching such missions, Earth. No amount of propulsion technology matters if ecosystems collapse. No interstellar dream survives environmental failure. Proxima B quietly reinforces this reality by showing how rare and delicate habitable conditions may be. Now consider the connection between interstellar ambition and planetary care. They are not separate goals. They are linked. A civilization that can stabilize its climate, can plan long-term projects. A civilization that can cooperate globally, can build interstellar infrastructure. A civilization that values science, can pursue deep space exploration. Proxima B becomes a test of readiness, not technological readiness, but civilizational readiness. Now consider what kind of future humanity wants, one built on extraction and short-term profit, or one built on sustainability and long-term vision. Interstellar exploration favors the second path. It demands stability, trust, shared purpose. This is not guaranteed, but it is possible. Now consider the emotional calm that comes from accepting limits. There is relief in understanding that humanity does not need to rush to the stars. The universe will wait. Stars will continue to shine. Proxima B will continue to orbit. What matters is not speed, but direction. Now consider the idea of legacy again. People often think legacy is about monuments, achievements, recognition. But true legacy may be quieter. A stable planet passed to future generations. A civilization capable of cooperation. Knowledge preserved. Projects continued. Proxima B becomes part of this legacy thinking. It invites humanity to think beyond individual lifetimes, beyond personal achievement, toward collective progress. Now consider the emotional image one last time. A small probe leaving Earth, accelerated by light, traveling through darkness. Years pass, decades pass. It reaches another star. It sends back data. Humanity listens, not cheering wildly, but quietly absorbing new knowledge. This moment will not be dramatic in the traditional sense. It will be subtle, yet historically enormous, because it will mark the moment humanity became interstellar in awareness, if not in presence. Now consider the closing reflection. Traveling to Proxima B in 400 years or 15 days is not the real comparison. The real comparison is between fantasy and responsibility, between impatience and wisdom, between escape and understanding. Proxima B teaches that shortcuts are unlikely, but growth is inevitable if humanity chooses it. Now allow this thought to settle. The universe is vast, the stars are distant, the journey is long, but the path is clear, not through speed, but through stability, not through force, but through cooperation, not through escape, but through care. And in that sense, humanity has already begun traveling toward Proxima B, not with engines, but with ideas, with knowledge, with patience, and with the quiet decision to become a civilization capable of lasting long enough to touch the stars. Not today, not tomorrow, but someday. And that someday begins here, on Earth, under this sky, in this moment, where the future of interstellar travel is not written by technology alone, but by the choices humanity makes right now. And with that understanding, this journey gently comes to rest, not at Proxima B, but at the place where every great journey begins, home. As the final echoes of this journey continue to fade, one last layer of meaning quietly remains. Not about distance, not about speed, but about perspective. Because Proxima B, in all its silence and distance, has already changed humanity, not by being reached, but by being imagined. Now consider how imagination shapes reality. Every major technological shift began as an idea. Flight began as observation of birds. Satellites began as equations. Space travel began as dreams written on paper. Proxima B now exists in this same mental space, a destination not yet reached, but already shaping design, research, and long-term planning. This is how futures are built, not suddenly, but gradually, through attention, through curiosity, through sustained interest. Now consider the importance of naming. Giving a world a name makes it real. Proxima B is no longer a catalogue number. It is a place in human thought. This changes how people relate to it. Names create connection. Connection creates motivation. Now consider how this affects younger generations. Children growing up today will learn about Proxima B in classrooms. They will not see it as exotic. They will see it as part of known space. This normalizes interstellar thinking. It prepares minds for long-term exploration. It plants seeds that may grow decades later. Now consider the idea of quiet milestones. Humanity often celebrates dramatic events, launches, landings, first footsteps. But some of the most important moments are quiet. Data analysis, scientific papers, gradual understanding. The discovery of Proxima B was such a moment. No explosion, no spectacle, just measurements, numbers, careful observation. Yet it shifted perception. Now consider the rhythm of science. Science moves slowly, carefully, methodically. This pace contrasts with public expectation, but it is necessary because precision matters. Interstellar exploration cannot rely on assumptions. It requires accuracy. Now consider how this influences patience again. Proxima B teaches humanity to accept slow progress, to value careful planning, to trust incremental advancement. This mindset is valuable far beyond space. It applies to climate action, public health, education, social development. Interstellar thinking reinforces long-term responsibility. Now consider the emotional maturity required. Accepting that some dreams will not be fulfilled quickly is difficult. It requires emotional discipline, letting go of instant gratification. Proxima B demands this maturity. It invites humanity to grow psychologically, not just technologically. Now consider the quiet connection between all these themes: energy, environment, education, cooperation, time. They all intersect in the story of Proxima B. It is not just about a planet. It is about civilization design, how humanity organizes itself, what it values, what it prioritizes. Now consider the idea of cosmic humility one last time. The universe is vast. Human existence is small. But small does not mean insignificant. It means precious. fragile, worth protecting. Proxima B reinforces this by showing that Earth-like conditions may exist elsewhere, but they are not guaranteed. They are rare combinations of circumstances. This increases appreciation for Earth, not decreases it. Now consider the future again. Perhaps centuries from now, humanity will develop propulsion systems far beyond current capability. Perhaps fusion engines will become routine. Perhaps interstellar probes will be common. Perhaps human missions will become possible. Or perhaps humanity will remain largely confined to its local star system. Both outcomes are possible. Proxima B does not guarantee a specific future. It opens a path. What happens next depends on human choices. Now consider what kind of civilization humanity wants to be. One that consumes and expands without regard for limits, or one that grows carefully, responsibly, sustainably. Interstellar exploration favors the second. It demands planning, discipline, respect for resources. Now consider the quiet ending of this story. There is no final arrival, no landing, no flag planted on alien soil, because the true ending is not physical. It is mental. A shift in awareness, a change in how humanity views the universe, from distant and unreachable to structured and understandable, from mysterious and abstract to complex and knowable. Now consider the last image. Earth rotating slowly, clouds drifting, oceans reflecting sunlight, Proxima Centauri glowing faintly in the southern sky, Proxima B orbiting silently around its star. Three bodies connected not by travel, but by understanding, by knowledge, by shared curiosity. Now consider what remains after all calculations are done, after engines are designed, after timelines are drawn. What remains is purpose. Why explore? Why look outward? Why invest in long-term projects? Because understanding the universe helps humanity understand itself. Because curiosity is part of being human. Because looking beyond the horizon has always shaped civilization. Proxima B is simply the newest horizon. Now allow this thought to settle. The journey to Proxima B is not measured in kilometers. It is measured in years of research, in generations of learning, in cultural evolution, in cooperation. And that journey has already begun, not in space, but on Earth, in classrooms, in laboratories, in conversations, in choices. And as long as humanity continues to ask questions, to learn, to cooperate, to plan for the future, the path to the stars remains open, even if arrival is far away. And that is enough, because the value of the journey is not found only at the destination, but in what humanity becomes along the way. And with that understanding, this chapter of the story gently comes to rest, not with an ending, but with an open horizon, quiet, wide, waiting, just like the universe itself. As this journey reaches its final quiet depth, one truth becomes impossible to ignore. Proxima B was never only about distance, it was about direction. Because when humanity looks toward another star, it is not escaping its world, it is redefining its future. Now consider the idea of continuity. Civilizations that last are not defined by how fast they expand. They are defined by how well they preserve knowledge, how carefully they manage resources, how patiently they plan across generations. Interstellar ambition requires all three. Without continuity, no star will ever be reached. Proxima B becomes a reminder that survival comes before expansion, stability before movement, wisdom before speed. Now consider the relationship between science and responsibility. Science reveals what is possible. Responsibility decides what should be done. Just because humanity may one day develop powerful propulsion does not mean it should use it recklessly. Interstellar technology can bring discovery, but it can also bring risk, radiation, energy misuse, environmental consequences, space debris, weaponization. Every technological leap carries consequences. Proxima B invites humanity to think carefully before acting. Now consider how this affects future generations. Children born today may never travel to another star, but they may help design the systems that allow future generations to try. Their contribution is not movement, it is preparation, education, innovation, stability. This is a quiet form of participation in interstellar history. Now consider the idea of collective effort. No individual will reach Proxima B alone. It will require thousands of scientists, engineers, technicians, teachers, policymakers, students, each contributing small pieces. Interstellar travel is not built by heroes. It is built by communities, by networks of knowledge, by cooperation across borders. Proxima B becomes a shared project, not owned by any one nation, but by humanity as a whole. Now consider the emotional maturity required for this level of cooperation. It requires trust, patience, tolerance, shared goals. These qualities are not guaranteed. They must be cultivated. Education systems, cultural values, media narratives, public understanding, all influence whether humanity becomes capable of long-term collaboration. Proxima B indirectly challenges society to improve these areas. Now consider the idea of cosmic responsibility. If humanity eventually reaches other star systems, it will carry its values with it, its ethics, its habits, its treatment of environments, its respect for life. Interstellar expansion without responsibility risks repeating old mistakes on a larger scale. Proxima B offers a chance to design a better approach from the beginning, one based on study, respect, minimal interference, scientific observation rather than exploitation. Now consider how this aligns with modern planetary protection policies. Space agencies already avoid contaminating other worlds. They sterilize spacecraft. They follow strict protocols. This shows awareness that exploration carries ethical responsibility. Interstellar exploration will amplify this challenge because consequences become irreversible across light years. Now consider the emotional image again. A probe traveling silently through interstellar darkness. No crew, no voices, just sensors and code, carrying humanity's curiosity. This image is powerful because it is humble. It does not dominate space. It simply observes, learns, reports. This is the most realistic model of early interstellar exploration. Not conquest, but observation. Now consider what happens when humanity receives the first close data from Proxima B. There will be excitement, but also reflection. What does this information mean? How should it be used? Should humanity plan human missions or remain focused on robotic exploration? Should resources be invested in propulsion research or environmental stability first? These questions will shape future policy. Now consider how Proxima B may change scientific priorities. Exoplanet research will become more targeted. Atmospheric spectroscopy, magnetic field detection, surface modeling, climate simulation. These tools will improve not only for Proxima B, but for thousands of other worlds. This expands humanity's understanding of planetary diversity, which helps answer fundamental questions. How common are Earth-like planets? How stable are habitable environments? How rare is life? Proxima B contributes to this broader picture. Now consider the psychological shift again. When humanity realizes that potentially habitable planets exist nearby, Earth no longer feels isolated. This can create two opposite reactions: carelessness or appreciation. One reaction leads to neglect, the other leads to protection. Science increasingly promotes the second, because while planets may be common, life-supporting conditions may not be. Earth remains unique in confirmed life. Now consider the deeper emotional truth. Proxima B does not replace Earth. It highlights Earth's value. It reminds humanity that even if other worlds exist, none are guaranteed safe. None are guaranteed accessible. Earth remains home, not temporarily, but fundamentally. Now consider how this realization changes long-term planning. Instead of focusing only on escape strategies, humanity may focus on sustainability, renewable energy, environmental restoration, population stability, education, global cooperation. These are prerequisites for any serious interstellar future. Proxima B indirectly encourages these priorities. Now consider the quiet irony. The more humanity looks outward, the more it is forced to look inward. Interstellar ambition becomes a mirror, reflecting weaknesses, highlighting strengths, exposing areas that need growth. This is the real value of distant worlds, not the worlds themselves, but what they reveal about humanity. Now consider the final emotional tone. There is no urgency to rush, no pressure to arrive tomorrow. The universe is patient. Stars live long. Planets orbit endlessly. Humanity has time, if it chooses stability. Now consider the final image of this part. Night falls on Earth. Cities glow softly. Satellites pass overhead. Somewhere far away, Proxima Centauri shines faintly, invisible to most people, yet present, waiting, not for humans, but for understanding. Now consider the quiet promise. If humanity continues to learn, to cooperate, to care for its planet, to invest in science, then one day, perhaps centuries from now, a new generation may look back at this era and say, this was when interstellar civilization began. Not with engines, but with awareness. Not with speed, but with responsibility. Not with conquest, but with curiosity. And that is where this story truly belongs. Not in the future, not on another planet, but in the present, in the decisions humanity makes today. Because every choice shapes the path forward. Every policy influences stability. Every scientific investment builds capability. Every educational effort grows understanding. And through these small, quiet actions, the journey to Proxima B continues, not through space, but through time, through culture, through progress, through wisdom. And as long as humanity continues to choose cooperation over conflict, knowledge over ignorance, responsibility over recklessness, the stars will remain open, not as destinations to conquer, but as mysteries to understand. And with that realization, this chapter of the journey gently fades, not with an ending, but with a calm horizon, a horizon not made of light years, but of possibility, waiting, silent, patient, just like the universe itself. As this long journey finally comes to rest, everything becomes quiet, not empty, not finished, just calm, because the story of Proxima B was never meant to end with arrival. It was meant to end with understanding. Now consider what has truly changed. Proxima B still orbits its star, 4 light-years away, silent, unreachable by humans today. Nothing physical has moved, and yet everything has shifted. Humanity now knows that another Earth-sized world exists around the closest star to the Sun. Humanity now understands that interstellar distances are not abstract numbers, but real barriers shaped by physics. Humanity now sees that the future of space exploration is not about rushing forward, but about building patiently. This awareness is the real destination. Now consider how rare this moment in history is. For most of human existence, stars were untouchable lights in the sky. No planets were known beyond the solar system. No nearby worlds were mapped. No interstellar missions were imagined seriously. Today, this has changed. Humanity stands at the beginning of a new era. Not an era of interstellar travel yet, but an era of interstellar awareness. This is the moment when humanity first realized that nearby stars are not empty. They host worlds, they host environments, they host possibilities. Proxima B symbolizes this transition. Now consider how this awareness will continue to grow. More telescopes will launch, more exoplanets will be discovered, more nearby systems will be mapped. The cosmic neighborhood will slowly become familiar, not traveled, but understood. This process will not be dramatic. It will happen quietly, through data, through research papers, through improved models, through careful observation. But its impact will be enormous. Now consider what kind of civilization can benefit from this knowledge. Only one that survives long enough to use it. Only one that remains stable, cooperative, educated, environmentally responsible. Interstellar ambition does not reward chaos. It rewards continuity. This is the deepest lesson Proxima B offers. Not about speed, but about endurance. Now consider endurance itself. Civilizations rarely fail because of lack of technology. They fail because of conflict, resource collapse, short-term thinking, environmental damage. Proxima B highlights this pattern. It shows that no engine can compensate for instability. No propulsion system can replace planetary sustainability. No interstellar dream can succeed if Earth collapses. This truth is not discouraging. It is empowering, because it shows humanity where to focus, not only on rockets, but on ecosystems, on education, on cooperation, on long-term planning. These are the real engines of the future. Now consider the emotional shift that comes with this realization. There is no urgency to escape Earth. No need to flee to distant stars. There is only the responsibility to care for the only world that makes exploration possible. Proxima B does not offer an exit. It offers perspective. Now consider the role of science one last time. Science does not promise miracles. It does not guarantee shortcuts. It does not provide fantasy. It provides clarity, and clarity allows better decisions. The story of traveling to Proxima B in 400 years versus 15 days is not about choosing speed. It is about understanding limits, and within those limits, choosing wisdom. Now consider what humanity becomes when it accepts this. A civilization that plans beyond election cycles, beyond individual lifetimes, beyond immediate profit. A civilization that thinks in decades, in centuries, in generations, This is the mindset required for interstellar exploration. Not excitement, but patience. Now imagine the far future again. Not tomorrow, not next century, but far beyond. Humanity may one day send fleets of probes to nearby stars. Perhaps fusion propulsion will become practical. Perhaps interstellar habitats will exist. Perhaps humans will travel slowly between stars. Or perhaps humanity will remain mostly within its solar system. Both futures are possible. But one thing remains certain. The path forward depends on choices made today, not in space, on Earth. Now consider the quiet beauty of this truth. It means the future is not controlled by distant stars. It is controlled by present decisions. Every effort to protect Earth strengthens interstellar possibility. Every investment in science builds long-term capability. Every act of cooperation moves civilization closer to the stars, not physically, but structurally. Now consider the final image. Night spreads across Earth. Cities glow softly. Telescopes scan the sky. Scientists analyze data. Students learn about distant worlds. Far away, Proxima Centauri shines faintly. Proxima B continues its endless orbit. Between them, no spacecraft travels yet. Only information, only light, only understanding. And that is enough, because the universe does not demand that humanity arrive quickly. It only offers the opportunity to learn, to grow, to become better prepared. Now allow this final thought to settle. The real journey to Proxima B is not measured in kilometers. It is measured in stability, in patience, in cooperation, in wisdom. And that journey has already begun, quietly, here, on Earth, with every choice humanity makes, with every generation that decides to protect knowledge instead of destroy it, with every effort to build instead of divide. And as long as humanity continues to move in that direction, the stars will remain open, not as destinations to conquer, but as horizons to understand. And so this story ends the way it began, not with speed, not with engines, not with arrival, but with silence, with distance, with calm, with possibility. A distant star, a nearby world, and a civilization slowly learning how to reach beyond itself. Not through force, but through patience. Not through shortcuts, but through responsibility. Not through fantasy, but through understanding. And in that quiet understanding, the future waits, wide, open, still, just like the universe itself.